Hi everyone, this video is going to talk to you about adding and subtracting rational expressions. So this goes in conjunction with homework 3-1, which is titled Simplifying and Undefined. You can do these first 3 questions from today. So we're going to skip past that. We're going to go to the second page which says adding and subtracting rationals. Remember, a rational is a fractional function. It's a function that has fractions, a polynomial, and a polynomial. So before we do anything, we need to review some basic properties of adding and subtracting with fractions. So the first example, 1a, shows that both of these have the same denominator. The bottom is 4. So if they have the same denominator, you're allowed to keep the denominator and you're allowed to add or subtract across the numerator. So 1/4 plus 2/4 equals 3/4 because 1 plus 2 equals 3 and you just leave the 4. So you keep the 4, which is the denominator. It's called a common denominator, which means it's in common and you're allowed to keep it, and then you just add and combine across the numerator. And then you would reduce if you could. So similarly here, example 1b, we have x values, and it's the same kind of thing here. We have a quadratic denominator, and we have the same denominator. So because they're the same denominator, you're allowed to keep the denominator, which is x squared plus 4x minus 21, and then you just add or subtract across the numerator. So we have x plus 7. And that's nice because now it's combined into one fraction. And then the last thing that we want to try to do is see if we can reduce this at all. And to do that, we would factor whatever we can. So if you look in the numerator, you got to leave it alone. But the denominator is factorable because it is a quadratic. So remember that we can do the AM method of factoring here. And you're going to get x plus 7 and x minus 3. Remember, the bigger number gets the middle sign, so 7 is bigger than 3, 7 gets the plus sign. So now, once we have this factored, we're allowed to reduce anything that equals 1. So you see here that we have x plus 7 over x plus 7. Anything divided by itself equals 1. So make sure you put that 1 in there and you don't just cross them out and not write anything, because the final answer is going to be 1 on the top in the numerator over x minus 3. Okay, so keep in mind that the x plus 7 over x plus 7 became 1, and we need to write that 1 in. If you don't write the 1 in, it's just going to be x minus 3, which is incorrect. So there you go. If you have the same denominator, it's pretty straightforward. Just keep the denominator and add or subtract across the numerator. That is what we're going to write down here. When fractions have like denominators, keep the denominators and add or subtract across the numerator to combine like terms. And then you would reduce if you have to. If you can reduce, you reduce. Okay, so keep the denominator and add or subtract across the numerator. All right, so that's something that should be reviewed. So now we have different denominators. So let's throw it back to some basic numbers. We see 4 and 2 are not the same. So the first thing we have to do is get what we call an LCD. An LCD is a least common denominator, which is the smallest number or the smallest multiple that both of these go into. So the LCD of 2 and 4 is 4, because 2 goes into 4 and 4 goes into 4. So when you rewrite this, you want to put 4 for both of them here. Okay, you could put it here or you could put it underneath if you prefer. Some people do it like this. And then basically what you want to do is you want to think about what's missing. How do I get to the LCD of 4? So the first fraction here, which I'll highlight in yellow, it already has the denominator of 4, so I don't have to do anything with it. I'm just going to leave it 1/4. Okay. But now the second fraction, 1/2, it needs to become a 4 for the denominator. So how is it going to get to 4? Well, it needs to be multiplied by 2. Now remember, you can't just multiply by 2 randomly. So what you have to do is multiply the top and the bottom of the fraction by 2. So basically, this is really 2 over 2, which equals 1, which is allowed. So now we end up having 1 times 2, which is 2, and 2 times 2, which is 4. So that's how we got 2/4. So basically what we did was we converted 1/2 into fourths. So now we have 1/4 plus 2/4. 1/4 plus 2/4 equals 3/4. We know that because now they have the same denominator. So the LCD is the least common multiple of the numbers in the denominator, okay? Now, could you have done a common denominator of 8? If you had just done 4 times 2, you would get 8. And the answer is yes, you could have done an LCD of 8, but it's not actually an LCD, it's just a CD. So if you wanted to, you could have done 8, and then it would have been times 2 over here. It would have been 2 over 8, and then times 4 over here, and 4 over 8, and you would get 6 over 8, but then at the end, you would have had an extra step because you would have had to reduce that down to 3/4. So basically, when in doubt, you could just get any common denominator. All right, let's move on. This one is 1 over x and 1 over 3. Clearly, they don't have the same denominator. One has an x and one has a 3. So we're going to let our LCD be both of these guys, x and 3. So we're going to write 3x, okay? So we want both of these to obtain the LCD of 3x. We're going to multiply by what's missing. The x as an x, but it needs a 3. So we're going to multiply the top and the bottom by 3, or 3 over 3, which equals 1. So we're going to get 3 times 1, which is 3, over 3x. Okay. Now we look at the next one. The next one is missing an x. It has a 3, but it needs to get an x to become 3x. So we're multiplying the top and the bottom by x, or x over x, which equals 1. So the numerator is going to become 1 times x, which is x, over 3x. Okay, so now they're both in terms of 3x, so we're allowed to keep the denominator the same, 3x, and add or subtract across the numerator. So we get 3 plus x over 3x. And now you may be saying, can I do anything with that? They're not like terms, so you can't combine them, and you can't cancel the x's out. That's illegal, so you just have to leave it alone. Okay, so now we have all of our steps, and we can get a little bit more advanced tomorrow. So let's go over what we just did. When our fractions have unlike denominators, the first step is get an LCD. You have to decide on your least common denominator. And my rule is when in doubt, you could just multiply them together and get a common denominator if you can't figure out what the least common denominator is. So first, decide on your LCD. Step 2 is multiply each fraction by what's missing. So, for example, in the above question, the LCD was 3x, and we want to basically achieve the LCD of 3x. So the first one of them was missing a 3, and one of them was missing an x. So multiply each fraction by what's missing in order to obtain the LCD. And that's that. And then once they have the same denominator, then you're allowed to proceed as if they have the same denominator. Then keep the denominators and add or subtract, aka combine, across the numerator, which is the top of the fraction. And then remember, at the end, last step is reduce if you can. So you may need to reduce by factoring and simplify at the end. Okay, there you go.